So now we're going to record a video of how we're going to actually separate these compounds to obtain a pure product C. So first we need to decide which eluent we are going to use for the column. Here's the column. This is found through trial and error by finding the optimal polarity for the compounds. So after you find the eluent, you're going to take a column and pour some of that eluent into there. And then we're going to pour a slurry of the silica and eluent combined into there. So that would be a slurry. Just getting it up there. Okay. So then we're going to let some of the eluent out. And now we're going to have to wet pack the silica. So we wet pack by tapping on the side of the column with a soft object to encourage the silica to settle. So we're just using a thermometer just to wet pack that silica. So another strategy we can use is we can use the vacuum system to actually blow air and encourage the silica to settle some more. So let's test to make sure that this is blowing air. Settle that silica. So that's another way that you can settle that silica. We want to make sure that the eluent level does not go past the silica level because it is detrimental if the silica dries out. We also do not want any air bubbles in the silica, and we want the silica to be long. If it is not flat or has air bubbles, it can mess up the rate of the compound slowing down, and therefore the actual fractions that we will use for the TLC. Put sand on top of the silica so that when we put our actual compound in and more eluent, we do not disturb the silica. So after wet packing the silica, it's all good to go and settled, we are ready to apply the mixture to separate. So we have dissolved the compound in a polar solvent, and we're going to apply it to the inner wall of the column with a pasture pipette. So let's get some of that. Let's apply it to the inner wall just so it goes down gently rather than just dropping it in and causing like ripples and causing the silica to be disturbed. So by doing this and spreading it equally all around the column, we have an equal interaction with the silica.
Next, we will add a few pipette amounts of eluent to gently fill the column, and we can add some sand if is your preference. Then we add much more eluent and then open the stopcock.
So there's some pipette amounts. Let's add some more actual eluent. Make sure to apply it equally to the sides. Okay.
We need to have test tubes under the column to collect fractions that will be tested by TLC. In our case, we don't have test tubes, so you're just going to have to use your imagination.
Okay.
Our TLC plate will then be labeled with a soft pencil markings a couple of centimeters above the bottom and not too close to the outside for different test tubes. Once we get some fractions, we will use a spotting pipette to pick up some of the solution and lightly but quickly tap it on the TLC plate where you will mark it where it should go.
Okay, so let's actually do this. We're going to take our spotting pipette, we're going to get an amount, and then we're going to quickly but lightly just tap it on there.
Then we need to decide which eluent to use for the TLC plate. This is also done by trial and error. We need one that causes the compounds to move halfway up the TLC plate. It also needs to make the ideal RF of approximately 0.3. We can find the RF by dividing the distance from the origin to the middle of the spot by the distance from the origin to the solvent front. If the RF is too high, the eluent needs to be changed to something less polar, like dichloromethane, for the example. If the RF is too low, the element needs to be more polar, such as methanol.
After time, when the solvent has moved up the plate, we can either actually observe the markings, use UV rays, or actually use a stain, which would have been applied to the element to actually visualize the results. So we can use a UV that would show the dots or the movement up here. So here's an example of one where you can see the actual markings moving up.
B will come out first in the fraction that is the least polar. It will want to move away from the silica. C will then come next, and then A because it is the most polar. So on the TLC plates, B will have the furthest path, and C will have the second longest, and A will not move much due to its polarity. We now have separated C from A and B, and we know which fraction it will be in due to the TLC